Notes for Lesson 5-6, Remainder and Factor Theorems. I know we haven't done division yet in this chapter, so we're going to do a quick how to divide things about halfway through the lesson. Hopefully, you remember that factors divide numbers equally. 3 is a factor of 9. And you know this because 9 divided by 3 is 3 without a remainder. The remainder is 0. Five is not a factor of 9. 5 is not a factor of 9 because 9 divided by 5 is 1.8. It's 1 with the remainder of 4. So the remainder theorem says the remainder of p of x divided by x minus r is p of r. That's what your development was on, plugging numbers into equations. The factor theorem says if the remainder is 0, then x minus r is a factor. So the remainder theorem tells you a quick way to decide if it is a factor. And the factor theorem just tells you, yep, it will be a factor when the remainder is 0, which should make sense from regular numbers. So an example. We are asking ourselves, is x minus r a factor? In order to decide that, we have to find the remainder. So step 1 is find the remainder. Which you find by evaluating p of r. And step 2 is, does p of r equal 0? If yes, then yes, it is a factor. If no, then no, it's not a factor. So, problem 1. P of x, our polynomial, is x to the 4th minus 6x minus 8. And we're going to see if x minus 2 is a factor. X minus 2. X minus r. So r equals 2. So we are going to evaluate p of 2. 2 to the 4th minus 6 times 2 minus 8. 16 minus 12 minus 8 is negative 4. Is negative 4 0? No. So it is not a factor. Your turn. Try example 2. So example number 2 is p of x equals x cubed plus 7x squared plus 7x minus 15. And we want to know, is x minus 1 a factor? So find r and plug it in. Take a minute. So we plug in 1 because r is 1. So p of 1 is 1 cubed plus 7 times 1 squared plus 7 times 1 minus 15, which is 1 plus 7 minus 15, which is 0. So is x minus 1 a factor? Yes, because the remainder is 0. Let's try one more time. P of x equals x cubed minus 5x plus 2. And we want to know if x plus 5 is a factor. X plus 5. It's supposed to look like x minus r. So what does r have to be to make it x plus 5? It has to be x minus negative 5. Agree? So r is negative 5. So you are evaluating p of negative 5. Please do so and decide whether or not x plus 5 is a factor. So we plug in negative 5 and we get negative 5 cubed minus 5 times negative 5 plus 2, negative 125 plus 25 plus 2 is negative 98. Is negative 98 0? No. So it is not a factor. So we use the remainder and factor theorems to decide if things are factors or not. Now we are going to use these theorems to find all the zeros. So let's take our yes answer from previously. So we're sticking with P of x equals x cubed plus 7x squared plus 7x minus 15 and x minus 1. I want to find all the zeros of that polynomial. And what we learned before was factor. But you can't split this in half and factor it. It doesn't work. So we're going to use our new information. We already decided that x minus 1 is a factor. And if something is a factor, you can divide by it and have no remainder. So we are going to use something called synthetic division. So this is something we have not yet learned. It's new, but it's pretty awesome. Synthetic division. You put R on the left-hand side, and I write my box as a backward L. So R is over there. We're going to put down all of our coefficients in a line next to R. The leading coefficient will drop down below the line, and the process is multiply and add. So that's how we're going to do it. So let's try. R is 1. So 1 goes over here. Our coefficients are 1, 7, 7, and negative 15. The leading coefficient drops below the line. We're going to take that number, the leading coefficient, times 1, the number in the box. 1 times 1 is 1. That new 1 is going to go underneath the 7. After multiplying, we add. 7 plus 1 is 8. Take this brand new number and multiply it by the 1 in the box. 8 times 1 is 8. After multiplying, we add. 7 and 8 is 15. Take this new number, 15, times the number in the box. 15 times 1 is 15. After multiplying, we add. Negative 15 plus 15 is 0. 0 is the remainder. Just like we claimed it was going to be, there is no remainder. When you take an x cubed and divide it by an x, you lose a power. So x squared is our first term. X is our second term. 15 is just a constant. So P of x is really our initial factor of x minus 1 and our new factor 1x squared plus 8x plus 15, which tells us that x could equal 1 is a 0. And then this other factor can be factored farther. Two numbers that multiply to 15 and add to 8 are 5 and 3. So it's x plus 5, x plus 3. And our other two answers are x equals negative 5 and x equals negative 3. Our cubic equation has three answers: 1, negative 5, and negative 3. We will try again together. So just give it a second to sink in. All right, problem number 5. P of x equals x cubed minus x squared minus 8x plus 12. And the thing we think is a factor is x plus 3. So step 1 is to find r, just like you did in the first 3 problems. So it's supposed to be x minus r, so it has to be x minus negative 3. So we're going to evaluate p of negative 3. So negative 3 cubed minus negative 3 squared minus 8 times negative 3 plus 12. This does give us 0. So is x plus 3 a factor? Yes, which is good, because that means we can use synthetic division, factor our answer out, and get all 3 zeros, which is our goal. So for synthetic division, we're going to put r on the left in a box. Then we're going to write down every single coefficient. 1, negative 1, negative 8, 12. To synthetically divide, you drop down the leading coefficient underneath the line. You take 1, our leading coefficient, times the number in the box. 1 times negative 3 is negative 3. After multiplying, we add. Negative 1 plus negative 3 is negative 4. Then we take that number that we just got times r, the number in the box. Negative 4 times negative 3 is 12. After multiplying, we add. Negative 8 plus 12 is 4. We take this 4 times r, the number in the box, negative 12. After multiplying, we add, and we get 0, which is good because that's the remainder. The remainder is supposed to be 0. If it's not 0, we did something wrong. So we're trying to divide x cubed polynomial by an x polynomial. And x cubed divided by x is x squared. So our first term, that 1, is now an x squared. Our next term is 1 less than that, so it's x. Our next term is 1 less than that, so it's the constant. So our polynomial is really our original factor, x plus 3, and our new factor, x squared minus 4x plus 4. Our goal is to find the zeros. So we set our first factor equal to 0, and we get that x is -3. Our other factor can be factored again. So we change it into x minus 2x minus 2. We set each factor equal to 0 and get that x also equals 2. And then you get that again. And you don't need to write it down twice. So we only have to write down 2 answers this time, -3 and 2. On page 354, I would like you to start off the problem. Look at problem 3. Do at least the first step. Decide if x minus 2 is a factor or not. Take a minute. So hopefully you plugged in 2. P of 2 equals 2 cubed minus 7 times 2 squared plus 4 times 2 plus 12. And that does equal 0. So yes, it is a factor. Next, you need to synthetically divide. So you put r in the box, it's 2. You write down all of the coefficients. Bring down the leading coefficient. Okay, if you haven't done so already, finish dividing that, please. So we brought down the leading coefficient. The next step is to multiply. 1 times 2 is 2. After multiplying, we add and we get -5. Next step is to multiply. -5 times 2 is -10. After multiplying, we add. We get -6. After that, we multiply. -6 times 2 is -12. After multiplying, we add. We get 0. The remainder is 0. It has to be 0. We took an x cubed and divided it by an x. So we have 1x squared minus 5x. And -6 stays the constant. So our polynomial is really our original factor of x minus 2 and our new factor x squared minus 5x minus 6. All right, take our polynomial, finish factoring it, and find all 3 zeros. Go. All right, x minus 2 is a factor and tells us that x equals 2. Two numbers that multiply to -6 and add to -5 are -6 and +1. So x also equals 6 and -1. 3 zeros for our cubic. Your homework is page 355, 4 through 7, 33, and 39.